Hey guys, how's it going? I want to go over how to solve systems of equation by substitution today. I don't want to spend a whole lot of time on this because we did do this before we were kind of kicked out of school and sent home to work on our own. So I just want to spend a couple days going over this. What I want to go over today is kind of like the first scenario you can have. Okay, so I put this sheet up on the website, and essentially we want to look at these first 10 problems today. If you'll notice, in these first 10 problems, they're all in slope-intercept form. Right, they're all in y equals mx plus b form. So I really want to get that down pat today, and then we'll start to take a look at some of these other examples where they're in different forms over the next few days. So I'm going to go over how to do the first 5 of these, and you guys can do the second 5 for homework. If you're thinking to yourself, like, can I just graph these? Yes, absolutely, you can just graph these. But just keep in mind in the back of your head that there will be situations where you'll have decimal answers, where graphing is not going to be a viable way to solve these problems. You're going to have to know another way. So this way works for decimals. Now, all the examples we're going to look at today will have integer answers, but we will start to look at some ones with decimals in the future. Okay. So let's just think about like what substitution is. Most of you guys should understand this concept. That say I give you some situation. I told you that y is equal to 4x minus 7. And I said that x is equal to 5. Right? Well, this is a system of equations, believe it or not, as simple as this one is. What would we do, though? You said x is equal to 5. So you guys would think, hey, everywhere I see an x, I'm going to replace it with a 5, right? So I say y is equal to 4 times, well, x is equal to 5, so I'm going to substitute in a 5 for x, right? And 4 times 5 is 20, and 20 minus 7 is going to be 13, right? So x equals 5, y equals 13. Now let's think about this kind of from a different point of view. What if I told you the other side? What if I said, you know, y is equal to, I don't know, 23, right? Well, everywhere I saw a y, I would replace it with 23, right? I would substitute in 23, right? And now we're going to have to do a little more legwork here, but we definitely can add 7 to both sides, right? And I'm going to say 4x is equal to 30. And I'm going to go ahead and I'm going to divide both sides by 4, and guess what I'm going to find out? Well, this is going to be a decimal, right? This is going to be what is it? 7.5. Okay. So the magical part about this is that if you do get a decimal answer, you can actually solve this. Now, if you were graphing this, you're not going to be able to tell that this is an accurate answer, right? When we graph things, we can only kind of tell what exists exactly on these intersections, right? So for it to be 7.5 doesn't help us. Also, the fact that there's 23 is way, way, way off our average graph, right? So the usefulness of the substitution method is it gets us out of some of these binds where we have decimal answers or large numbers. Like if your number was 3,000, it's not going to fit on your coordinate plane of 10 by 10. So yeah, could you graph it? Yes. Could you scale your graph? Yes. But to be frank with you guys, it's a little more straightforward to go ahead and just solve some equations this way. Actually, let me just leave that. What's going to change for some of the examples that we're looking at is this. Well, I'm going to substitute in for y. Everywhere I see a y, I'm going to replace it with what's over here. The difference is that we're going to have an x in what we substitute. So I'm saying y is equal to negative 3x. So everywhere I see a y in my second equation, I can replace it with negative 3x. Okay? So here's what I'm going to do. Everywhere I see a y, I'm going to replace it with negative 3x. Okay? So in this equation, what am I going to say? I say, well, it's not y anymore. It's negative 3x is equal to 6x minus 9. Now, again, I saw this y. What do I want to replace it with? Well, I know y is equal to negative 3x, so I can plug that in there. All I want to do now is I just want to go ahead and solve this, right? So pretty basic equation solving. I need to get all my x's on one side and all my numbers on the other, right? Well, since I only have x's over here, I'm going to go ahead and move the rest of the x's there. Negative 3x minus 6x is negative 9x. What's left on this side? Just a negative 9. I'm going to divide this side by negative 9. Divide this side by negative 9, right? This is negative 9 times x. So to undo that multiplication and divide by that same number. On this side, negative 9 divided by negative 9 is 1. Well, now I've got x. How do I find y? Well, the same way we have in the last week or so. I'm going to plug it back into this equation right here, right? So I'm going to say y is equal to negative 3x. Well, everywhere I see an x now, I can substitute, right? So again, there's more substitution right there. So we're going to say y is equal to negative 3. So let's go ahead and let's express our answer. Okay, now what if we wanted to check it? So we think our answer is 1, negative 3. Well, if you want to check it, take your answers, plug them back into the other equation over here. Okay, so let's plug it back into the other equation. We'll say, well, we had y is equal to 6x minus 9. Well, everywhere I see an x, I'm going to replace it with a 1. And wherever I see a y, I'm going to replace it with negative 3. And as long as the statement is true when I'm done, this will be true. Negative 3, well, 6 times 1 is 6. And 6 minus 9 is negative 3. Okay? So since negative 3 equals negative 3, then we can check and we can make sure our answer is correct. Okay? So again, there's two ways to look at this. You could say either we're substituting in, or you could say we're setting these two things equal to each other. In other words, they're both equal to y, therefore they both have to be equal to each other. Okay? There are two different ways to look at the same problem. Okay? But essentially, long story short, what's going to happen, everywhere you see a y, you're going to replace it with this right here, whatever's on the other side. Okay? So the next one gets a little more complicated in the fact that you have a variable and you have a constant. So make sure we're still recording. We're still recording. Okay. So y is equal to x plus 5. So everywhere I see a y in the next equation, I'm going to replace it with x plus 5. So what am I going to say? Well, it's not y anymore. Now it's going to be x plus 5 is equal to negative 2x minus 4. Right? In other words, I replaced this y with this x plus 5. Why? Because it was also equal to it. All right? Now, you have to decide what do you want to move where, right? Now I have variables on both sides, right? And I also have constants on both sides. It doesn't matter. You just got to pick one and start moving. If we think about this, if we want to keep working with positive numbers, we should probably start by adding 2x over here and 2x over here. Negative 2x and positive 2x is 0. So what's left? Negative 4. Here I have 2x and another x makes 3x, and I'm going to bring down that positive 5. Well, now that I decided to bring all the x's to this side, all the numbers got to come over to this side. Okay, so I'm going to start with this 5. Okay, so I'm going to subtract 5 on this side, subtract 5 on this side. Bring down the 3x, this cancels out and becomes 0. Negative 4 and negative 5 is negative 9. Okay, so again, I moved all the x's to one side, moved all the constants to the other, and always, whenever you can, try and leave your division for your last step. So this is 3 times x. The opposite of multiplication is division. Negative 9 divided by 3 is going to be negative 3. Okay, now we're going to plug back that. We're going to plug that back in to solve for y. I would suggest using the first equation. Okay. Again, why? Because you just have the x by itself, right? You didn't no multiplication, so a little bit simpler. So we're say, we got y is equal to x plus 5. Let's substitute in negative 3 for x, right? Because we said x was equal to negative 3. Negative 3 and 5 is going to be 2. So our answer is negative 3, 2. If you want to check your answer, plug it back into the other equation. Y is equal to negative 2x minus 4. Y is going to be 2. And x is going to be negative 3. Well, negative 2 times negative 3 is 6. 6 minus 4 is going to be 2, so it works, and this is our answer. All right, so what do? We substituted in, we moved all our x's to one side, we moved all our constants to the other side, we divided, we got x, plugged it back into this one, got y, and to check, we plugged our x and our y into the other equation. All right, so again, what do we got here? Y is equal to negative 2x minus 9. So everywhere I see a y, I can replace it with negative 2x minus 9. Good. Now again, what do I want to move? Again, I see this negative 2x. I want to stay positive, so I'm going to add 2x here and add 2x here. Could you have subtracted 2x from both sides? Absolutely. Okay. It's really up to you. Okay. Now that I got my x's on this side, I need to get my numbers over on the other side. Opposite of minus 1 is plus 1. I got a 4x. Negative 9 plus 1 is going to be negative 8. And again, whenever you can, leave your division to the last step. So x is equal to negative 2. Good. Again, you guys can move these around however you want. The big thing is this. All your x's got to get on one side. All your numbers got to get on the other side. So when you're done, if you prefer the x's on the other side, move the x's to the other side. It doesn't matter. Okay. But again, now that we've got this, let's plug it back in. I'm going to plug it into the second one this time, right? So I'm going to say that y is equal to 2x minus 1. So we're going to plug into the second one. It doesn't matter. So y is equal to 2 times negative 2 minus 1. 2 times negative 2 is negative 4. Negative 4 minus 1 is going to be negative 5. So what's our answer? Negative 2. Negative 5, and if we want to check, let's plug that back into this first one just to make sure it works. So we're going to say y is equal to negative 2x minus 9. Sorry, I said to pause it because my wife came to tell me dinner's done. Okay, so what are we doing? She's here mostly. You want to say hello?
Hi.
Okay, so we're going to go ahead and we're going to plug in this negative 2 here for x. And it's negative 5 here for y. And my wife, Melissa, is going to tell you that negative 2 times negative 2 is
0.
4. 4 minus 9 is, and 4 minus 9 is, 4 minus 9?
Negative 5.
Negative 5, very good. Okay. You want to do the next one with me?
Definitely not.
Definitely not.
I have no idea what's going on right now.
Okay. All right, last one. Last one. You want to watch?
Sure.
Okay. So again, we're saying that y is equal to negative 6x plus 3. And we have also y is equal to 6x plus 3. So everywhere I see a y, I'm going to replace it with
Wait a second. When you
negative 6x plus 3. Okay. So what am I going to do? I'm going to say negative 6x plus 3 is equal to positive 6x plus 3. So we're going to add 6x to both sides. Babe, 6x and 6x is?
Well, that's to the left side would be 0.
Very, very good. This would be 0. And on this side, 6 and 6 is?
12.
Good.
Good job, Kit Kat.
Okay. The cat is here too. We're going to subtract 3, and 3 minus 3 is?
0.
0. So 12x equals 0. So what's x?
1.
0.
0.
Right? 12 times 0 is 0, yeah?
Oh.
Oh, okay.
12 divided by 12.
That's 1. That's 1x. That's this side. Okay, so now we're going to take this 0 and we're going to plug it into this equation right here. Say y is equal to negative 6x plus 3. So y is equal to negative 6 times 0
Which is 0.
plus 3. Yes. So, and what's 0 plus 3?
3.
3. So we're going to say that the answer to this problem is 0, 3. And if we want to check it, we're going to plug it back into this equation right here. So say 3 is equal to 6 times 0 plus 3. Does 3 equal 3? Yes. Good? Does that mean we can go eat dinner now?
Mhm.
Let's go eat dinner now. All right, guys. I hope this helped. Again, I did the first 5. I want you guys to do the next 5. I want you guys to do 6, 7, 8, 9, and 10. Please send questions if you have them, okay? Thank you.
Questions?